Okay, I've been hearing from quite a few of you today, which makes me so happy because I know that that means that you're working on getting ready for the quiz tomorrow. And I, I, I know that this whole school closure means that you really have to take more accountability for your learning. Okay, I am posting these videos. I'm trying to email you back and answer your questions, but it just doesn't beat being in person. So I just want to make sure you're taking account, you're doing the work. If you're going to be successful, you really have to take on a lot more accountability and make sure you're putting in the effort and the work. I have answered a lot of emails about these three problems, 1, 3, and 6, so I'm going to quickly go over them. I talked about this one earlier this morning, actually, in my video. I am not going to make you graph something like this. If you were to graph this here, you would have to make a table or graph it in terms of x and flip it. I'm going to make you graph things like x equals y squared. X equals y squared minus 3, that kind of thing. That's what you would have to do. But this one with the 3 y's in here, that would be really hard to graph. By the way, I should go ahead and apologize for any background noise. I've got lots of kids running around me right now. So if it gets loud, I apologize. So this one, there is no way up here that we are going to, that we are going to solve for y and do this in terms of x. We have to do this in terms of y, and that's because, again, there's no solving for y right here. Okay, we're going to have to keep that the way it is, meaning we've got to do this in terms of y. So starting, thinking lowest, bottom to top, or not bottom to top, left to right this time, which means lowest to highest, okay? So I'm going to start with this bottom area, this one right here. This area, y values, stretches from the y value, -3, to the y value 0, okay? And for that area, since we're doing this in terms of y, that means we're doing right minus left. And the right curve is actually a vertical line. That's the vertical line, x equals 0. So technically, it starts with 0 minus, and then it's -y cubed over 2 minus y squared over 2 plus 3y. Okay, so that is right, x equals 0, minus left, x equals that crazy thing, dy. Okay, so you'll have to plug that into your calculator, but then that's plus, now we need to do this area right here. And that stretches from the y value 0 to the y value 2. We're okay here. Okay, so from 0 to 2, right minus left, this time right is -y cubed over 2 minus y squared over 2 plus 3y. Vincent, shh. Okay, so that's right, and then minus left. Left over here happens to be, again, that x equals 0. So it's technically minus 0. Just a reminder that oftentimes your limits of integration are either places where they intersect or like a horizontal or a vertical line. Okay, so then you need to plug this into your calculator, and I don't know, the answer I know is on PowerSchool Learning, but that would be this one. Okay, this one here, something unique, yes, you can eat those. Something unique about this one is that you can, I didn't show you how you could look this up online, but you can plug in x equals lines into your calculator. It's not that hard to do. I bet you could find a video on it. But you don't need to. But when you look at this in your calculator, you're not seeing these vertical lines that I have right here. And that does make it harder when you're then looking at those vertical lines, which is maybe another reason you should also be sketching these on your paper, because you can for sure put those x equals lines on your paper. When you put those x equals lines on your paper, then you see this bounded area, and it is clearly two different spaces, okay? This one we can just do in terms of x. So if we do this first area right here, this almost like triangle little space, that goes from back to x, so my boundaries are x values, x equals -1 to x equals 0. And from -1 to 0, it is the line -2x minus the quadratic. So I'm going to go ahead and, well, yeah, minus, and then make sure you're using parentheses, -x squared plus 4x dx. Okay, so then plus this area right here that goes from x equals 0 to x equals, where's that line? 3. And for that one, it is the quadratic minus the line. Okay, -1 to 0, and just that. Okay, yeah, that's right here too. Okay, and you end up getting, what is it? Is that one 21? Oops, that one's 21.33. Okay, and so then last one, this one right here, I don't know if I'll write up, but again, as you look at this on your calculator, you don't see any bounded area, because on your calculator, again, you might, unless you look up how to do this, you can't see those x equals lines, which is another reason you should be maybe sketching this on a piece of paper. But if you sketch it on a piece of paper, you can see the area a little easier. It's that little piece right there. And just doing this in terms of x is going to be pretty easy. So I'm actually going to go back here instead of writing this out. Okay, so it's just from x equals 1, which is that vertical line, to x equals 3, the other vertical line. And top curve minus bottom curve, well, the top curve in this case is the horizontal line, 4, minus this rational function right here for number 6, and you should get 10.66. I just wanted to talk about one more thing. This is getting longer than I meant it to be, but I did get a few emails about this one. This answer that I have on my key is not right. It's not 40. I think it's, I want to say 24, but don't quote me. That's number 17. If you're working on that one and not getting the answer I had, that's why. Please email me if you have any more questions that I just want to make sure you're ready for the quiz.